So, our first lesson is on statistics, and some of this, most of it, hopefully, is going to review, but it is important that you understand it. I'm going to do it in two parts because of the restraints of the technology I'm using to upload to YouTube. But we're going to start just by reviewing some basic statistics. So you guys should already know these, but they're called the descriptive statistics, and there are three of them. The mean being the sum of all the x values divided by the number of values, which is the average. The median is the middle number. The important thing that you need to know about that is that it has to be the middle number in an ordered set. All right, so this means that you first of all have to put all of the numbers in order from least to greatest, and then you can find the median. And then, of course, the mode is the most frequently occurring number. Now, these don't necessarily tell you the whole story. They tell you some things about the data, but not necessarily everything about it that you want to know. And I just found this little comic that I thought was kind of funny. So you can take a minute to read it. It's kind of amusing. But it does bring up an important point, and that is that statistics sometimes, if not often, are used to prove that things are the case that maybe aren't. And you can make statistics say a lot of things that you might want. So, for example, you could say that 4 out of 5 dentists recommend a toothpaste. If you've only asked 5 dentists, that doesn't really represent that 80% of dentists do that, but you could argue that 80% of dentists do because of that. So you have to be careful with statistics. We're going to talk about some ways not only to describe them, but also to represent them visually. And again, these things might be reviewed for you. I hope they are, but they may not be. So to represent data, there are two types of data that we're going to talk about: discrete data and continuous data. And it's important that you understand the difference between those. Discrete data has discrete values, which means you can only be 1 or 2 or 3, for example. You can't be in between, whereas continuous data allows for that in-between stuff. So, for example, a discrete data would be the number of people that are doing something, because you either have one person doing it, or 2 people doing it, or 3 people doing it. You can't have 1.5 people doing it, or 1.25 people doing it, unless those people are not full people, and that doesn't really make sense. There might be some other issues there. However, continuous data is things like height of people, because you can have any height, and it's allowed to be, 196.532 centimeters. So that's the difference between discrete and continuous data, and you will see in a histogram that discrete data there are spaces, because we're saying, for example, this is 1, this is 2, this is 3, this is 4, and so on, and there's nothing in between. Whereas here, you might have a range. So you might say 1 to 2, and then 2 to 3, and so on. So that is the difference between continuous and discrete data. A histogram is used when you have no gaps. A column graph is what you use when you're using discrete data. So it's very similar, it just there's gaps in a discrete data column graph, and there's not in a histogram. The way a histogram works is the frequency of whatever the data is on the y-axis. So that means how often it occurs, whereas the data itself is on the x-axis. So your data ranges, for example, for height might be 120 centimeters to 130, 130 to 140, and so on. That's on the x-axis. And then the frequency, the way it's reported, can either be a value, like it occurs 5 times or 10 times or 12 times, or it can be a percentage of the data. So you could say 30% of the time it's in this range, 40% of the time it's in that range. So it's normally grouped into intervals because of the continuous nature of the data, but those differences in interval are dependent on what data you're talking about. So, for example, if you're finding the height of all women, then there's a tighter data range, or the height of all men, there's a tighter data range, and you would say the height of everybody, because men and women typically have a higher range together than they would if you were just looking at one or the other. If you're looking at things like the height of plants, for example, or flowers or something like that, the size of flowers, that you might use a smaller data range because the data is more compact. So it's just, you have to decide what those are based on what you're looking at for data. So that is a histogram. So we have mean, median, mode, we have a histogram, and then we have another type of representation, which is called a stem and leaf plot. And essentially it's called a stem and leaf plot because you have a stem, which is the first number, and then you have a leaf, which is the second number, or sometimes another part of that number. So for example, here, the stem is the first number. We're talking about 2-digit numbers. So this is the second number. So this would be 53, 55, 56, 60, 61, 62, 64, and so on. And what that allows you to do is just sort of see the shape of the data. In other words, how is it grouped? So there's more in this data in the 60s than anywhere else. And there's none below 50. And you can kind of see that if you draw a curve over top of it. In this case, you can have a stem and leaf plot very similar, except that in this case, this is a decimal point. So it's 3.7, 4.0, 4.4, 4.8, 4.8, and so on. So you order the data from least to greatest, and then you just pick a leading number, or you could pick leading numbers. If you're in the 500 and something range, you might want to put 50 here, and then 501, 502, 503, and so on. It's up to you what your stem is and what your leaf is. But generally speaking, you're talking about the first number being the stem and the other number being the leaf. And you essentially get a sideways histogram in some senses. If you kind of look at the shape of this graph, if you tilt it on its side and rotate it, you kind of get the same shape. So that's the benefit of stem and leaf. You can't necessarily find mean, median, mode better here than in the other one. It's just a different way to represent the data. So when you compile data, typically you get this kind of shape, not sheep. And it's called a bell curve because it looks kind of like a bell. And generally speaking, the mean and the median are in the middle. So your middle number and your average are in the number. Okay, so it's possible that happens. It's also possible that you get sort of a weird looking bell. All right, so if it's normally distributed, it looks like that. If it's got some skew to it, if it's kind of bent, then you will see either positively skewed data or negatively skewed data. If it's positively skewed, it means the mean is higher than the median, so the middle number is actually lower than the average number, which just means that you kind of get it shifted to the right. You get this sort of view here where you have, and then negatively skewed data, the mean is below. All right, so I'm not sure why I have two curves on here. Let me just get rid of this one. But you can see positive and negative skew, what they look like, and they're just kind of bent in a slightly different way. That this is not directly in the middle, and they're not symmetrical on either side. So there's more of a curve on this side than the other side, and so you can get positively skewed or negatively skewed data. And so you're not necessarily going to see it visually. You can often, but even if the mean and median are really close to each other, you can have positive or negative skew, just it's slight. So at this point, really all you need to know about these things so far is just how do I create them, how do I represent the data, and how do I find the mean, median, and mode. That's what you're looking for.